All right, I think the trick with a problem like this is to just take it one part at a time and not get overwhelmed by it. Otherwise, that part C over there can kind of freak you out, but it should be easy if you take it in steps. So getting started with the recursive or implicit definition here for part A, you could, up to you how fast you want to go about it, but this rule right here is basically saying just keep adding 3 to get the next term. So right there, that's an indication that you're dealing with an arithmetic where the common difference is 3. So if you can quickly generate the terms by understanding it that way, then you have my permission to do so. If, however, you need to show some steps just to keep it straight, then you could do that thing where you just use this function rule and then start at k equals 1 and see what it says. So if k was 1, it would say a sub 2 is a sub 1 plus 3. A sub 1 is negative 5, so you'd have negative 5 plus 3, which would be negative 2. So there you go. You could ask it what would happen if k was 2, and it would tell you a sub 3 would be a sub 2 plus 3. And sooner or later, you'll see like, oh my goodness, this thing is just arithmetic, and they just keep adding 3. My goodness. Anyway, so you'd have negative 2 plus 3, which would be 1. So you could keep up at this. You could totally just do this, and it will always work. But sooner or later, I'm hoping that we're all just comfortable with, just keep adding 3. So if I just keep adding 3, I'd get 4, and then let's see, first 5. So I'll add 3 again, and then indicate that it could keep going that way, and practice using those beautiful braces. All right, let's see. For part B, it says write an explicit formula for the nth term of the sequence. So that's what we did in the beginning of this lesson. So let's talk about how to jump to the nth term. So you would take negative 5, and you just keep adding 3s. And, how many 3s would you add to get to the nth term? You'd add n minus 1 of them. There you go. Feel free to simplify that all you want. I'm not gonna. All right, now for part C, it says evaluate the sum as I goes from 3 to 10 of a sub I. So taking this in baby steps, the first thing I think I would do is replace a sub I. Now that we know the rule for a sub n, I would just put that in here. So, and actually, I'm going to go back on what I said earlier. Maybe I do want to simplify it. Do I? Nah, never mind. I'm not going to take it back. So we're just going to replace all the n's with i's. So you have negative 5 plus I minus 1 times 3, fighting the urge to treat I like the imaginary number. So now that I've got this, if in doubt, expand it out, right? So let's plug 3 in. Your lower bound is 3. So we'd have negative 5 plus 2 3s. So that'd be 1, right? And then now you can plug 4 in. So negative 5 plus 3 3s, right? You can plug 5 in. Negative 5 plus 4 3s. So 7. Anyway, and if you look at my terms, oh, okay, well, they just keep adding 3. Anyway, and then you could jump to, I'm going to leave a couple blanks. I always like if you start with 3, which we should always start with at least 3. I like it if we end with 3, unless, if it helps. So let's see, let's show the last term. Let's jump to plugging 10 in. So negative 5 plus 9 3s. So negative 5 plus 27, so 22. And then I can work backwards. So if you add 3 to move to the right, you'd subtract 3 to move to the left. 2. Okay. So I know I left some middle terms out, but I'm too lazy to write 10 number. Actually, it wasn't even 10. Oh my goodness. I could have just written them. Whatever. Anyway, so let's do our trick. First plus the last term, 23. Second plus second to last, 23. And, yep, 23. So how many 23s would we have? How many 23s? Well, you could actually look here. You would have had 10 numbers in your list, but we started at 3. So we skipped 2 numbers. So there are 8 numbers in the list. So by using that plus ... notation, I saved myself writing 2 numbers. Anyway, so we've got 8 numbers in the list. So how many pairs of 23 would we have? Yep, we'd have half of 8. There you go. And so your answer would be whatever 4 times 23 is, which would be 80 plus 12 or 92. There we go. Now notice I did not use that pretty formula that I put in the bubble, but had we used the formula we put in the bubble, I claim that like a lot of the work that I just did, you would have had to kind of do anyway. You would have had to have figured out, I guess maybe it would have been a little easier, but sum of the first, and I guess we're going from 3 to 10, so you had 8 terms. Would have been the number of terms, which would have been 8, divided by 2, times your first term, which I expanded it out to figure that out, plus your 8th term, and then you could have been in the same place we were, just kind of thinking it out a little bit. So there you go. You have options. If in doubt, expand it out, make your pairs, figure out how many pairs, or use the formula. There you go. All right. Hopefully things are making sense, my friends, and hopefully you'll ask me questions for the parts that don't. Take care, everybody.